Hello student, welcome back to my channel Kunal Sir at JEE NEET Chemistry World. After a long day, we came to discuss some topic in our channel, and thank you all of you for supporting me and following my channel. Today again we will discuss very important topic from the physical chemistry part in ionic equilibrium, buffer capacity. Let us look at what is called as a buffer capacity. So now everybody knows the weak acid and its salt, or weak acids and its conjugate base used to form a buffer solutions. Like if you take few example, like if I say, so acetic acid and its salt, sodium acetate form buffer solution. Or if I say HCO3 minus and its conjugate base, nothing but a salt of carbonate, can form buffer solutions. Not only like a H3PO4 and its conjugate base like a H2PO4 minus, that can form a what? Buffer solution. These are acidic buffer. And then other one we can say few example like a NH4H and NH4Cl, like a weak base and its conjugate acid, like a primary amine and its conjugate amine, like conjugate acid used to form buffer solution. Conjugate base means after losing the proton species as called as a conjugate base, after gaining the proton piece is called as a conjugate acid. Now this is nothing but a acidic buffer, and the other one is nothing but a basic buffer. But my aim is not to explain the buffer solution and the basic thing. Today the important topic what I want to explain today is buffer capacity, that how we will say which buffer is good and which buffer is not good. Because the buffer capacity is nothing but a buffer capacity, by definition wise what we know, buffer capacity is nothing but a, what is buffer capacity? Number of moles of H plus or OH minus need to add to change the pH, one unit. That is nothing but your buffer capacity in 1 liter buffer solution, within bracket, in 1 liter buffer solution. So that means what is buffer capacity? In 1 liter buffer solution, number of moles of H plus or OH minus need to add to change the pH 1 unit is called as a buffer capacity. Now mathematically if I explain that one, how it will be look like, the buffer capacity will be equals to mathematically if I explain, dx by d of delta pH. That means what is x? X is a number of moles of H plus need to add, and this delta pH is unit of pH change, that is a buffer capacity. Now already we know the buffer solution, how to find out the pH and that formula. What is that? If you look at for pH of a buffer solution, for acidic buffer, let us look at for acidic buffer, everybody knows buffer solution is that solution which resists the change of pH due to small additions of H plus or OH minus. Now for acidic buffer, the pH will be equals to, pKa plus log of concentration of conjugate base by concentration of acid. Rather than that, some book will say concentration of salt by concentration of acid. That means the anionic part, it is mainly coming from the salt. That's why concentration of salt by concentrations of acid. Otherwise, always remember it's a concentration of conjugate base, nothing but the anionic part. So that's why pH will be equals to pK or plus log of concentration of salt. Salt means the anionic part of the substance, salt by concentrations of acid. This is the pH of that buffer solution. How to find out the pH? Now if you look at initially suppose I am giving a one problem. I have a two buffer. One buffer is 0.1 molar acetic acid, 0.1 molar acetic acid mixed with 0.1 molar sodium acetate. And next another buffer is there, 0.2 molar acetic acid is mixed with 0.2 molar sodium acetate. Now I am asking you, which buffer solution has a more buffer capacity? Now that type of problem I want to discuss. That's why I choose a topic, how to find out the buffer capacity. Now suppose I am telling the acid concentration is nothing but A and the salt concentration is nothing but a B. For both cases, here this is A and here this is A and here this is B, the concentrations of the acid and salt. Here also this is 0.1 molar, here also this is 0.2 molar. Now let us look at how we can get that idea which buffer has a more buffer capacity, like that. In case of a buffer solution, how can I explain that phenomena? Now if you look at to explain that one, what we need to be done? So initially suppose I am taking a one solution. Suppose I have a like this, a mole of acetic acid mixed with a mole of acetic acid mixed with b mole of sodium acetate, b mole of sodium acetate, b mole of sodium acetate, b mole of sodium acetate. Sorry, if you look at these things, I am rubbing and I am writing so that you can clearly observe that one. What I am telling, a mole of acetic acid mixed with b mole of sodium acetate, to get the buffer solution. An entire solution, if you look at this entire solution, volume of the solution is 1 liter. That means molarity both cases is nothing but a molar acetic acid and b molar sodium acetate. They form a buffer solution, as simple as that. Now in this solution, if I add x mole of NaOH, now what is the scenario going to happen? Now we need to look at that one. Suppose if you look at, in first case my pH will be equals to, in first case when we didn't add the NaOH, that time I am telling pH1 will be equals to log, pH1 will be equals to pK, pH1 will be equals to pK of the acid plus log of concentration of salt by base. So concentration of salt means salt is B molar and concentration of acid is A molar, that is a B by A. Now this is my equation 1. Yes or no? Now if you look at, when I am adding x mole of NaOH to that solution, then what are the things are going to change, that we need to look. Then if you look at, when we are adding x mole of NaOH, then what is going to happen? This is my equation 1. Now that time what is going to happen? Who will react? The salt will react with the acid will react with the corresponding base. Salt will not react with the base. Then who will react? Salt will react with acid, but the base will react with what? Acid. The salt will react with a acid, but the base will react with what? Acid. Now here acetic acid react with a NaOH. So that's why acetic acid, and we are adding NaOH, how much? X mole. Now acetic acid was there A mole per liter. Now we are adding here NaOH X mole, and X is a very little amount we are adding compared to A and B. Now If you look at, then who will react? Naturally NOH will be my limiting reagent as it is a smaller. So then out of X, X will be reacted. After reaction it will be 0. Out of A minus X amount will react, and acid and base reaction means salt and water. Then here we will get the salt. Which salt we will get? Sodium acetate. How much amount? X amount. And now with that water. Initially my salt was there B mole per liter. Now additionally X amount form. Whereas initially my acid was A mole per liter. Now it is A minus X. That both the concentration is changing. That means now new pH will be equals to, I am telling pH2. pH2 will be equals to acid, same acid, that's why pK value will be same. pK, here I am telling this is a pH2 because pH will change as their concentration is changing. So that's why log of salt by acid, salt concentration, now it will be how much? B plus X. Acid is how much? A minus X. Now you look at, as we are adding the OH, that means in a solution OH concentration is increases, that's why pH of the solutions will increase. That's why we can say pH2 is greater than pH1. What is the logic? The logic is, if OH of the concentrations increases, then naturally my OH concentrations will be greater than the H plus concentration. When the OH concentration is greater than H plus concentration, then my pOH will be decreases. pOH decreases means pH will be what? Increases. That is the simple logic. Now we understood that pH2 is greater than pH1. Then if I do, this is my equation 2. Then if we do, then pH2 minus equation 2 minus equation 1. If I do that operation, pH2, I am going to the next slide. You look at pH2 minus equation 2 minus equation 1 we are doing. Then if I do that one, equation 2 minus equation 1, if I do, then what is the equation? pH2 minus pH1, which is nothing but I am writing delta pH. Delta pH is nothing but what? pH2 minus pH1. And now pK will be cancelled out. You look at this one. Here what is happening? Initial slide what we discussed, both the things was there. Then here you look at pH2 minus pH1 is a delta pH. Then pK cancel out. Then what we will get? 2 minus 1. And then this log B plus X by log A minus X minus of log B by A. Then what we are getting over here? We are getting over here, if you look at, delta pH will be equals to log of B plus X by A minus X minus of log of B by A. We are getting this one. Now you look at this part, log B plus X and log A minus X, I am writing like this way. Delta pH will be equals to log of B plus X minus of log of A minus X, because we know log A by B will be equals to log A minus log B. This is the formula. समझा करो यार. Log B by A will be equals to log of B minus A, log of log B minus log A. Log B by A will be equals to log B minus log A. This is the formula. Now here we are getting delta pH will be equals to log of B plus X minus log of A minus X. Now what I am doing over here, differentiating with respect to X, then what we are getting over here, d of delta pH by dx will be equals to, so what is the formula? d dx of log of B plus X will be equals to 1 by B plus X, and with X, d dx of X equals to 1 and sign is plus, no issue. Now here what we will get? Here we will get log of A minus X means A 1 by A minus X, and minus X at differentiation. That means here minus will come, and minus this value will be what? Plus. And now you look at here, there is a minus log of B by A is there, which is a constant term, differentiation will be what? 0. So now if you look at, we got delta d of dph by dx equals to 1 by b plus x by 1 minus a minus x. Now if you look at, before this way we can proceed, another way we can proceed, log I can convert in terms of a ln. For that purpose, this is one way of doing. We can proceed this way. Another way what we can do, I can change the log into the ln. That means how I will change from this step. You look at here, delta pH will be equals to, I am doing delta pH will be equals to, I am writing 1 by 2.303, and here it will be multiplied by 2.303 of log of b plus x minus of 2.303 of log of a minus x. That means we are getting this one. Now if you look at 2.303, log of that one is nothing but a natural log ln. So then immediately what I can write down, delta pH will be equals to 1 by 2.303, 1 by 303, and instead of 2.303 I can write down ln b plus x minus of ln a minus x. We can write down like this. Now again here I can do a differentiating with respect to x. Then what I will get, d of delta pH, because maximum people will proceed with this approach with ln, but by log also you can proceed, no issue. You can get that one, same thing what I want to mention. So that same thing you will get over here, what I want to reach. Now differentiation with respect to x, then immediately delta of delta pH by dx. And now here we are getting 1 by 2.303, and differentiation of ln b plus x will be equals to same idea, 1 by b plus x, and here minus of a plus of 1 by a minus x. Why plus? Because differentiations of ln a minus x is a 1 by a minus x, and minus x is there, before that minus sign is there, minus minus will be what? Plus. And we got delta pH by dx equals to this value. Then you look at, I am going to the next slide. In the next slide, what I can write down, here I am writing delta of delta pH by dx will be equals to 1 by 2.303, and here we are getting 1 plus 1 by b plus x plus of 1 minus 1 by a minus x. Now if I do these things, and then here we will get like this, d of delta pH will be equals to by dx, which will be equals to 1 by 2.303, and here if I do these calculations, this will be b plus x into a minus x, and this will be your a minus x plus b plus x. Then x cancelled, you are getting a plus b by b plus x into a minus x. Now here I am telling, if, because the amount of x will be very very small, so that's why x will be, your x will be what? Your x will be very very smaller than a, x will be very very smaller than b. Then what I can write down? I can write down delta of delta pH by dx will be equals to 1.2303, which will be equals to a plus b by a into b. Now these things if I change, that means denominator if you take in a numerator and numerator if you take in a denominator, then what I will get, dx by d of delta pH, which will be equals to 2.303 ab by a plus b. That means what I want to mention over here, my buffer, this is nothing but your buffer capacity. Then buffer capacity will be equals to, buffer capacity is proportional to AB by A plus B. That is we reached. 2.303 is a constant term. So that's why initial problem we started, you remember, I told you there are two things is there, 0.1 molar acetic acid mixed with 0.1 molar sodium acetate, and another buffer we took it 0.2 molar acetic acid mixed with 0.2 molar sodium acetate, and I asked you which has a more buffer capacity. Now this one is your A and this one is your B. Then already what you need to find out? AB by A plus B. If AB by A plus B is more, my buffer capacity will be more. That's why if you look at here, what will be the situation? 0.2 into 0.2 by 0.2 plus 0.2. If you calculate this value used to come nothing but a 0.1. Now, whereas if you look at for this value, for this if you calculate 0.1 into 0.1 by 0.1 plus 0.1, this value is to come 0.05. So if you look at these things, both the cases, that means in this case my AB by AB plus 2 is coming more. That's why it has a more buffer capacity. So that's why this is the very important parameter we reach. The buffer capacity is directly proportional to AB by A plus B, or maximum buffer capacity will be equals to AB by A plus B. 1 year JEE Advanced asked the question based on this idea. What they are giving a one graph where the maximum buffer capacity was there and how you can calculate AB by A plus B. Is it clear? I hope you enjoyed the video. To get this type of more video, please come to my channel, subscribe, give your comment, which chapter, what topic you need the clarity. I am the Kunal sir, ready to give you clarity about the chemistry regarding JEE Mains, JEE Advanced and NEET. Thank you very much. Thank you all and see you soon in the next video.